Hello everyone, and welcome to a lecture on finding the missing element solution. So let's go over the problem statement one more time. Consider an array of non-negative integers. Then a second array is formed by shuffling the elements of the first array and deleting a random element. Given these two arrays, find which element is missing in the second array. So for an example, we have this array, this list, and then the second array, a list. Something to take note, I'm saying the term array, but that's just to be agnostic about which programming language we're using. So in an interview setting, you'll be asked about arrays. In Python, these are just lists, as we said before in the beginning of this section. So again, I get one array as a Python list, a second array as a Python list. The second array has shuffled elements of the first one and a deleted random element. Your function should be able to find that random element that was missing. So let's talk about solution and theory and logic. So the naive solution, just brute forcing it out, is to go through every element in the second array and then check whether it appears in the first array. Note that there may be duplicate elements in the arrays, so you would need to pay special attention for that. The complexity of that approach is order n squared, since we would need to do 2 for loops for that. A more efficient solution is to sort the first array. So while checking whether an element in the first array appears in the second, we could do a binary search. We'll learn more about binary searches in more detail in the searching and sorting section of this course. But with that solution, you still need to be careful about duplicate elements. The complexity of that solution is order n log n. If we don't want to have to deal with that special case of duplicate numbers, we can sort both arrays and iterate over them simultaneously. Once the two iterators have different values, we can stop. The value of the first iterator is the missing element. So this solution is also order n log n. So let's go ahead and do the solution for this approach. Let's jump to the solution notebook and code it out and explain along the way. So what we're going to do is define our finder function. Takes in the arrays. We'll go ahead and sort the arrays. So now that the arrays are sorted, we're going to compare elements in the sorted arrays. So for num and num2, num1 and num2 in, I'm going to zip the arrays together. And I'll show you what zip does in just a second in case you're not familiar with it. It's a bit of a Python trick as far as simplifying our code and making it clear to read. And then I'm going to return the first element if I don't get a return of the first number there. So I'm going to explain zip first, and then we're going to walk through this entire code. As far as what zip does, it essentially just zips together lists. So if I pass in lists like this, 4, 5, 6, the output is a zipped up matching pair of the tuples. So I get 1, 4, 2, 5, 3, 6. So it takes the first element, puts them together of each list, second element of each list, puts them together in a tuple, third element of each list, puts them together in a tuple. So it returns a list of tuples, and I'm doing tuple unpacking here in order to grab those elements. So continuing on, let's go ahead and walk through our solution. First thing we're doing is we're sorting both arrays. So we're sorting both arrays, and then we're saying for those numbers and those pairs, as we go along the indexes, if the number of the first array isn't equal to the number of the second array, then we know we're just going to return the number of the first array because it was missing after we sorted them. Otherwise, we're just going to return the last elements of the first array. So let's go ahead and copy some code to test out this problem or our function solution. This was the example at first, and we got 5 out. All right, great. So in most interviews, you're actually going to be expected to come up with a linear time solution. We can use a hash table and store the number of times each element appears in the second array. Then, for each element in the first array, we're going to decrease this counter. Once we hit an element of 0 count, that's the missing element. So let's go ahead and check out this solution. We're going to learn about hash tables in a more formal manner later on in the course, so don't worry if you don't understand full hash tables right now. But in order to do this, what we're going to do is take advantage of Python and its collections module. So I'm going to say import collections. Let's go ahead and do that. All right. So we're going to do a default dict from collections module, which is just a dictionary in Python where if the key isn't already in the dictionary, it will automatically add it for you. All right. Let's go ahead and use it. So our second solution looks something like this. I take in both arrays, and this is where collections comes into play. I'm going to say D equals from collections, a default dictionary that takes in integers. So all this does is allows us to avoid key errors. So if the key isn't in the dictionary, instead of throwing up an error, it's going to just add the key to that dictionary. All right, so what I'm going to do is add a count for every instance in array 1. So I'm going to say for num, and actually let's do this for array 2. I'm going to say for num in array 2, dictionary num, add 1. And then I'm going to check if the number isn't in that dictionary. So I'm going to say for num, in this case, the first array, so we're going to say R1. If that number's count is equal to 0, return num, because we never counted it. And otherwise, I'm just going to say else that number is going to be subtracted. So let's go ahead and check the solution, and then we're going to walk through this. All right, so that looks like it worked and matched up. Let's go ahead and check it on our second one by putting in finder2 here. Also worked. Great. So let's go ahead and walk through this. What are we actually doing here? Well, we're importing a default dictionary. And again, this is the same as a normal Python dictionary, but if the key doesn't already exist, there's no error, you just add the key. So I'm going through the second array, and I'm counting how many times each element shows up. So I'm saying for number in array 2, set that key plus 1. Note, I'm avoiding the little if statement, so if num in dictionary or D, because I'm using a default dict. So that's what allows us to write this as one line right here. If you try doing this with a normal dictionary, this line would throw an error if num wasn't already a key in the dictionary D. But with default dict, we're allowed to do that. So, as I mentioned, we go along the second array. For every number in it, we add a count. Then, in the first array, what we're doing is for num in array 1, if it's equal to 0, we return num. Otherwise, we're going to subtract 1. All right, so there's two other possible solutions, one of them which we're going to code out, and the other one we'll talk about. The one we're going to talk about is just, you could compute the sum of all the numbers in array 1 and then array 2, and then subtract array 2's sum from array 1's sum, and that difference would be the missing number in array 2. However, this approach could be problematic if the arrays are too long or the numbers are very large. You could end up getting an overflow when summing up the numbers. Or if the numbers are really, really small and have a ton of decimal places, you may lose some information. So your interviewer probably actually wouldn't like that approach. Even though you might think it's pretty clever, algorithmically and in a programming sense, it has trouble. If the arrays are too long or the numbers are very large, you could get an overflow issue. So I would recommend mentioning it, but also mentioning the problems with that solution. Here's the clever trick version. So you could achieve a linear time and constant space complexity without any problem. And the way to do that is you could initialize a variable to 0 and then do an exclusive OR of every element in the first and second arrays with that variable. So what's an exclusive OR? If you go to the solution notebook and scroll down here, this is what we're at right now. By performing a very clever trick, you can do an exclusive OR. And an exclusive OR basically is a bit comparison. And you can read about it more on the Wikipedia link here. And we're going to go over this exclusive OR. We'll see it again in another interview problem. So don't worry about understanding the solution completely right now. You'll see it again later as far as the exclusive OR. And what it does is it shows outputs when the inputs differ. So if your input is A and B, if it's 0, 0, your output is 0. If one of them is 1, then you get 1. If one of them is 1, you get 1. If they're both the same, you get false. So by performing this kind of clever trick, basically what you do is we scroll down here, initialize your result to 0, and then perform an exclusive OR between the numbers in the array. So for num in these sum here, R1 plus R2, we're actually just adding lists, remember that. So if I do this in Python, let me just copy and paste that to show you what it does. If we take these two arrays and add them together like this, then we're just basically concatenating the arrays together. We're not actually summing each element. So then you say for num, the result, do an exclusive OR with that number, and then just print the result so you can see it as it goes along, and then return the results. So this is kind of a clever trick, and I wouldn't expect you to know it right off the bat. And we're going to go much deeper into exclusive OR because it shows up in another interview problem as a really good solution, and not just a clever trick solution. So don't worry if you don't completely understand this last solution. We're going to see it again later on in this course. Make sure you do understand this solution right here, and if you don't understand the default dict, then try implementing the solution of just a normal dictionary. And then remember, you could have also sorted the elements, but make sure you understand the problems with the order complexity of this solution. Alright, that's it for finding the missing elements. Thanks, and I'll see you at the next lecture.